And welcome in, everybody. Welcome into our class here on unit conversions. So in today's class, we are going to get into it with the annoying thing about unit conversions, which is going to be, how do I know when to multiply or divide? I think that's the biggest headache question that we can ask ourselves when it comes to unit conversions. And that's going to be our step number one here. We're going to learn how to convert units, and with confidence, because there's nothing worse than second guessing yourself in the middle of a word problem. We don't like that at all. So number one, we're going to learn how to convert units with confidence. And then when we move into those word problems, we're really going to focus on avoiding common mistakes. So that way you can make sure that from start to finish, you have done something meaningful at every step, as opposed to stopping, second guessing, wondering, and then ultimately giving up. We don't want that. There's always something we can do. And then number three, we're going to get into word problems, and then we're going to continue increasing the difficulty. And if we don't get through everything in tonight's class, don't worry. In the next class, if you're watching this as a recording, or if you're here live tomorrow, we're going to go ahead and continue with multi-step word problems for unit conversions. So essentially, you're going to get almost 4 hours of unit conversions practice. And by the time we're done, I think that you'll be in a very good position, at least in a much better position than we were before. So let's go ahead and get right into it here. Let's start taking these notes on converting units. So here's how we're going to play this. I'm going to go ahead and go through these notes, and then from there, we will go ahead and take some time, take the notes down. That way you can just sit back, relax, and watch me get this done. So let's go ahead and start off here. Let's kick things off. Let's start with converting units themselves. Two options here. I got two options for you. Number one, to convert one unit to another, we can go ahead and use a conversion rate. So what a conversion rate is, my party people, it's basically using a fraction to cancel the old unit out and leave the new unit. One more time, let me say that one more time. A conversion rate is a fraction, so something that you put over something else, allowing you to cancel the old unit and leave the new unit. Now, for some folks, that might be a little complicated. And the only reason I think it's complicated is because we might want to use this rule to start off. This rule still works exactly the same way, except this will tell you instantly, instead of you guessing, whether you need to multiply or divide. So let me go ahead and give you this example here. Everybody, give me a yes in the chat box. Do you see the example? We are trying to turn 3 feet into inches. Let me know that you see that there. Perfect. Now, let's go ahead and zoom on into this right side. And again, I'll be zooming out to let you take your notes momentarily. But let's take a look at this. Everybody, when we are comparing feet to inches, which one of these is the bigger unit? Is 1 foot bigger than 1 inch? Or is 1 foot smaller than 1 inch? Which way does it go? Correct. A foot is bigger than an inch. So what I can mark down here, and I'm going to let's use red to do this. I'm going to mark with red. I'm going to say that feet is the bigger unit and inches is the smaller unit. And notice how I am comparing, everybody. I'm not saying that feet is always going to be the big unit. Because if it were yards, yards would be the bigger unit. So remember that we're comparing in the moment. Compare the units. Is what I have bigger or smaller than what I'm trying to get to? In this case, a foot is bigger than an inch. So that's how I've done step one. Literally just identify, am I going big to small or small to big? From here, once we figure that out, once we know if we have big to small or small to big, then that's going to tell you what rule you're going to be using. So let me go ahead and just show you a nice little example here off to the top right. Let's say I have this ruler that I'm going to draw without any help from technology. Perfect. And let's go ahead and say we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, and 12. 12 inches. Everybody, think about it like this. When we go big to small, we multiply. Why is that? The reason is because when I take 1 foot and I turn it into the number of inches that it represents, when you have a big unit going to a smaller one, you're breaking up that unit into a bunch of smaller units. You'll have 12 inches because you break it up into a bunch of those smaller units. And that's why you multiply. When you have a big unit and you're going to a small unit, you are breaking it up into a ton of smaller pieces. And that's why, in this case, we would multiply. And if you wonder, why would you divide? Well, the reason that you would divide is when you're going the opposite way. Let's think about it like this. Everybody, when I have a bunch of inches, is it true or false that when I'm trying to turn inches into feet, I gotta find out how many groups of 12 inches I can make? True or false? If I'm going from inches up to feet, I'm grouping up all those inches to see how many feet I can make. Yeah, that's true. Now, everybody, what's another word for grouping? How many ways you can group something? Is that division? If I'm trying to group up a bunch of things, like how many groups can I make? Yeah, that's division. If I'm going from a small unit to a big unit, you're dividing because you're seeing, hey, how many groups of this unit can I make that will be that next unit? So if you are having any trouble at all converting units, this is going to be that saving grace for us. So I want us to begin here by writing this down. For converting units, if you're going from big to small, we're going to go ahead and multiply. If we're going from small to big, we're going to go ahead and divide. And whether or not you're confused on the overall general idea, no worries, because this is one of those things that if you memorize this, you'll have a much easier time once we get into the actual practice. So let's go ahead and continue here. Let's go ahead and actually solve this conversion. But before I actually even show you with this little trick or this little rule, let me just go ahead and show you visually. And I think the best way to learn something is to see what's going on. So everybody, let me go ahead and begin by drawing up right over here. Let me grab this and let's duplicate that and move you over here. Okay, everybody, how many feet did this problem say we have? We have 3 feet, right? So there's 3 feet side by side by side. So with that, my party people, let's think about it. How many inches are in 1 foot? Who memorized that already? How many inches are in 1 foot? Yeah, that's going to be 12 inches, right? 12 inches in 1 foot. So let's write that down here. We have 12 inches right here. This is 12 inches as well. And 12 inches right there. Everybody, quick question. Quick question. How many feet did we have that we're trying to convert again? Yeah, that's 3. So just remember this. If we're adding the same thing 3 times, that's the same thing as multiplying. And so we have 3 of these feet multiplied by 12, and that's going to give us what, everybody? Yeah, that's going to be 36. Super straightforward. And I think when we look at it that way, it makes a ton of sense. But remember, we're not here just to handle the easy numbers. We have to prepare for those more complicated examples. So with that said, here in this case, 12 plus 12 plus 12, that's just 12 times 3. And that's exactly what happened here. That's how we are going to get the 36 inches. Because every foot is broken up into 12 inches. And that's why every foot that we have, we multiply by 12, because we're going from a big unit to a smaller unit. Again, big to small, we are multiplying. Let's go ahead and show that here. 3 feet times the conversion, which is 12 inches a foot, or 12 inches per foot, and it's going to give us 36 inches. Just like that. Now, let's go ahead and think about going backwards here. Let's say we have something to the effect of, over here, let's go ahead and say randomly, let's say I have 48 inches. And I want to take 48 inches and turn it into feet. Everybody, tell me real quick, are we going from big to small or small to big? In this case, we are going to be going small to big. That is correct. And remember, every time you look at this, I don't want you to memorize. I want you to analyze. 2 different things here. And so what we notice is that we are starting from inches, ending on feet. between these two specifically, which one is smaller? And that's going to be the inches. So we're going from a small unit to a big unit. And when that happens, what you're saying is, let me just write that here, small to big. And what we're saying here is, hey, with these 48 inches, we know that every 12 inches is a foot. So we're going to find out how many groups of 12 that I can make. How many groups you can make translates to division. Making how many groups out of a big total, that is division. And so in this case, we would divide by 12. And everybody, 48 divided by 12, y'all already got me in the chat box. That is going to be 4 feet. So at least with these smaller examples that we're doing here, is it making even a little more sense in terms of why we would multiply in one case and why we would divide in another? Right on, good start. So then with that said, again, this right here, I'm gonna just slightly, only slightly. I need y'all to go ahead and make sure that that is written down at the top of your page. Big to small, we will multiply. Small to big, we will divide. Give me a got it in the chat box if that makes sense. And we are going to move forward here to the conversion rate, showing you that as well. Sweet, sounds good. Cool. And I'm glad I got some chuckles. So with that, let me just quickly show you how we can use a conversion rate whenever you're not sure if you need to multiply or divide, because a conversion rate will honestly just reveal it on its own. So let me show you. Everybody, we know already that 1 foot is 12 inches. Really quick question though. This is something that we all know here. Every single one of us knows this, but I'm going to ask it anyway because the way that this makes sense is through your initial understanding here. Quick question. How do we get rid of or, quote, cancel a certain number or unit? Is it by dividing? Yeah, if we divide the same thing over itself, we get cancellation. That's what happens. So everybody, the same thing holds true when it comes to messing around and converting units. Check this out. Everybody, if we have 3 feet right here, well, 3 feet is technically going to be on the top, technically. So if we want to get rid of the unit feet or foot, where would I have to place the 1 foot? On the top or on the bottom? Again, the 3 feet is technically up top right here. Where do I need to put the 1 foot? To cancel it. Yeah, to cancel it, it's going to have to be on the bottom. And then the 12 inches, well, there's only one other place for it to be. And so that's going to go up top. Now, everybody, quick question. Let me just make sure I'm not trying to trick anybody. Isn't it true that 12 inches and 1 foot are the same exact thing? 12 inches and 1 foot, that's the same length, same distance. Cool, sounds good. Just making sure we all know. These are the same exact thing. So we could cancel these out if we wanted to, but it's not these that I'm going to cancel out. It's actually going to be the unit for foot or feet. That's what I'm going to be canceling out. Because guess what? Guess what's left? Straight up inches. That is what is left. And because the 12 is up top, we are multiplying by 12. Everybody, what's 3 times 12? It's not like we just did this a million times. Yeah, 36. And yes, the rule here with conversion rates is basically cancel the old unit to leave the new unit. Cancel the old unit, leave the new. Just like that. That's the premise. Cancel the old unit through division, putting it on the bottom, and then putting the new unit that you want up top. When you do that, it'll reveal itself automatically, because if that 12 was down here, you'd be dividing by 12. But because the 12 is up top, you are multiplying. And that's really it. This can guide you, with converting big to small, small to big. Either way, it just takes care of itself if you place these numbers in the right spots. So no worries if that didn't make too much sense, because it's honestly going to take some more practice. I gotcha. But here's where I want you to always resort and reflect back to, right over here. If you're going from a big unit to a small unit, multiply by that conversion rate. Small to big unit, divide by that conversion rate. With that said, my party people, who here is ready to try another example before word problems? I'm not going to torture you yet, but who's ready to try some examples out? Sweet, sounds good. So let's go ahead here and try this next one out. So let's go ahead and try to convert 32 ounces into pounds. So automatically, right over here, everybody, let's think about ounces and pounds. Can anybody tell me first, what is the conversion between them? How many ounces is how many pounds? Can somebody give that to me in the chat box? I see the number 16. I see 16 ounces. 16 ounces is what? Be more specific. Ariane, appreciate you. 1 pound equals 16 ounces. Let me write that down right over here. Cool. 1 pound equals 16 ounces. So, with that said, everybody, if we're going from ounces to pounds, are we going from small to big to small? Which way are we going? Yeah, we're going small to big. Remember, you need to group up 16 ounces just to make 1 pound. This is the smaller unit. You need a bunch of these units to make 1 pound. So we are going from small to big. Everybody take a look at your notes. What did we say? What operation are we using if we're going from a small unit to a big unit? What did we say? Yeah, if we're going from a small to a big, your notes say division. Boom, right there. So because we know we are supposed to divide, let me just write that down right over here. This equals division. We can be confident about this. We know we're supposed to be using division. And everybody, what's the number that we're going to divide by? Yeah, 16, right there. Boom, that's all you need. That's all you need. Remember, every conversion is always going to be one of this unit equals however many of the other. You're going to use that number that's not 1. That's the number you'll use right there. So in this case, we can automatically get our answer by taking 32 ounces and dividing by 16. Just like that. And pop quiz. How many times does 16 go into 32, my friends? Yeah, it goes in there twice. So when we divide by 16, our final answer is going to be 2. 2 what, everybody? We went from ounces to what? 2 pounds. Exactly. Right there. So does that help anybody out there seeing it in action again? Again, step 1, are we going from small to big or big to small? And as soon as you figure that out, you know exactly what operation you're going to be using, and you already know what number so long as you've memorized that conversion. So yeah, that's what it's all about, making your life easier than it was before. And to show you the other way, to show you how the division would happen with the actual conversion rate, let me just show you that example here. So again, everybody, we have 1 pound equals 16 ounces. Given that we already have ounces and we're trying to get to pounds, everybody, we are trying to eliminate or cancel out ounces. Yes or no? Is that true? Again, we are starting with ounces, so I want to cancel out ounces to just get pounds, right? Cool, awesome. So with that said, think with me, come on, think with me here. If this ounces is technically up top in the fraction, because remember, everything is divisible by 1, so you could just write it like that. So technically this is up top, technically speaking. So if we regard it like that, like it's already up top, where do we need to put the 16 ounces to cancel it out? Exactly, we want to put it on the bottom. Ounces up top and ounces on the bottom will end up canceling out. And on the top, you'll put the other part of it, the 1 pound. So because the 16's on the bottom, that's how you'll know you're going to divide. And you can see that if ounces are up top and ounces are on the bottom, the unit ounces, it goes away. We've canceled the old unit and we will leave the new unit. We have 32 divided, again, because it's on the bottom, divided by the 16, and that's going to give us 2 pounds. Just like that. And again, everybody, I fully admit we're using relatively smaller numbers, more, pleasing numbers. I know, for sure. But what we need to understand is the mechanics here. We're trying to get rid of the old unit so we can leave the new one. And so if, again, we are having a little bit of trouble understanding the conversion rate, we can always fall back to this rule here. Big to small, multiply small to big, divide. Who here prefers that method there? Who here prefers the big to small, small to big? Right, number one. And who here prefers the conversion rate, number two? So give me a 1 or a 2. 1 for the big, small, small, big, and then 2 for the conversion rate. Okay, looks like the majority of us are saying 1. We got a couple of 2s in here. Right on, shout out to you, you're my favorite. Now let's go ahead and continue getting some practice in. Let's keep trying some things out. But before we do, I want to make sure that we at least have the benefit of the doubt of having the unit conversions laid out for us. So here's what we're going to do. We're going to look here. We are going to take down these notes for the conversions for US customary units. Then we'll talk about metric units. And then from there, we are going to see some of this in action with some word problems. So let me go ahead and go back to US customary, and I'll give you a moment here to write this all down. All right. So these are our conversions for metric units. And so take a moment if you're watching this as a recording to pause the video here, but we've gone through US customary and metric units. And let's go ahead and dial in to our first word problem of the day. So for those of you who have been here before, my party people, quick question. What do we do with all word problems? What's the very first thing that we do? Now, as always, in the live class, we see a ton of folks using the 3 same letters, RTQ, RTQ, RTQ. Now, the people that are a little more forgiving will go ahead and spell it out, and it means read the question. That's what RTQ stands for. That's the first thing we want to do. Not read the entire problem. This is the whole problem. We mean the question sentence. So in this case, we don't have an actual question, but we have a demand. We have a command here saying, express this length in feet and inches. Let me go ahead and highlight that right there. Boom. So before we even get started, everybody, does it make total sense that the goal here is whatever the heck we're going to read up here, we need to turn that into feet and inches. And if you look at the answer choices, it kind of supports that too. We have feet and inches. Feet and inches. Yeah, do we agree or not there? Right on, and we should. Now, once we have that, once we know what the question is actually about, what we're actually trying to solve for, then the next thing is, let's take down the information. Let's understand what's important, what's not, and we can only do that by just going through the story. But we know what the goal is. We want feet and inches. So here's the story here. Sarah is making a banner for the school dance. The length of the banner measures 83 inches. Okay, everybody, quick question. Quick question. It says 83 inches. Is that already in feet and inches? Is that already in feet and inches? No, it is not. Might seem like an obvious question, but this is the mechanic that you want to kind of go through. Basic strategy. Ask yourself, do we have what we need? Oh, we don't. We only have inches. So then it looks like the goal is figuring out how to turn 83 inches into feet and inches. That's what it sounds like we're trying to do. Now, what does this look like, everybody? If we're trying to go from inches to feet and inches, can anybody tell me what that sounds like to you based off of your notes? What does it sound like we're trying to, do here? Oh, now I see a lot of folks saying divide, and I see a couple of other folks saying small to big. Yes, right on. When you take a look here, you're trying to go from inches to feet and inches. Really just want to focus here on the feet, and you think, hey, when I compare inches and feet, which one is the smaller one? And you can absolutely say inches. Inches is smaller than feet. And if you take a look at your notes, booyah, we have division. When we are going from a small unit to a big unit, we will divide. Now, this is going to be the first time that we're doing it in today's class, working with a remainder, and I'm going to gracefully show you how we take care of that. So with that, everybody, what's the number that we're going to be dividing by? Because I see the word division there. Sure, I wrote it down. I got that right. But you have to remember your conversion rate, and that is 12. Correct. So let's bring it all together here. We know that 1 foot equals 12 inches. And so this is what we're going to be dividing by 12. So let me go ahead and zoom on in over here. And let's divide right here, 83 by 12. Let me show you that right there. Boom. And then 83. Here's how we're going to do this when it comes to unit conversions. Everybody, first question, how many times does 12 go into 83? Right, that's going to be 6. Because everybody help me out, 6 times 12 is what? 6 times 12 is what? 72, correct. So let's write that down. We're going to have 6 as the quotient because 12 goes into 83 6 times. 6 times 12 is 72, so that's what we're going to subtract. Everybody, 83 minus 72 gives me what? Yeah, that's going to be 11. So just pause right there and take a look. We have 11 left. Quick question, my party people. What do we call that number that's left over at the end of long division? Give me that R word again. Yeah, that's the remainder. That is the remainder. And guess what, everybody? That is going to be the remaining number of inches. Remember, we started from inches. We're trying to see how many groups of 12 fit into 83. And we have 6 groups. So that's 6 feet that we can make. The 11 that's remaining, that is the remaining number of inches. And so with that said, the final answer is going to be 6 feet and 11 remaining inches. If I had 12, that's a whole nother foot. That would have been 7 feet. But here, we don't have a full 12 inches. We have less than that. So that remains as a leftover number of inches. Our correct answer here is going to be 6 feet, 11 inches, and we are all done. Let me zoom on out. That's the problem right there. Correct answer is A. And there we go. So my party people, for anybody here who was nervous about using that technique, small to big, big to small, how do you feel about this? Does it feel like this is a technique that would serve you well as we get into bigger problems? Good. That's what I'm looking for there. Again, we have to build confidence in small, doable steps, because remember, it's always impossible before it's possible. It's always possible before we're good at it, and then we're always good at it before we're great at it. So we have got to take it little by little. And again, yeah, I know we want to work towards that timer side. I know for sure. But we have got to give ourselves the time and patience to get it right before we get it quick. So give yourself that time. So what I'll do here is I'll take a quick pause, go ahead, write down what you need to write down, and then we're moving forward to the next practice problem. Now let's go ahead and move forward here to the next problem. So in this example, same thing. We will start by reading the question sentence. Everybody, what are we trying to look for? What are we trying to obtain here at the end of this situation? What do we want at the end here? What is it that we want? Yeah, I see the word total for sure. That's definitely something we'll want to highlight. Yeah, now we got to add a little more context to it, right? We need a little more story with that, because total could mean a bunch of different things a bunch of different ways. But when we say we need how many pounds and ounces of flour in total, that makes a lot more sense. We want to know at the end the grand total of pounds and ounces. Okay, boom. Now that we know what we're trying to end up at, let's begin understanding what we have to work with. The way I like to think about it is, what do we want? The question. What do we have? The information. And what's the connection? Translating that English into math. So here we go. What we have here is a recipe calls for 2 pounds, 5 ounces of flour. Okay, let me highlight that right there. We have 2 pounds and 5 ounces for the recipe. And then what we need to do here says, if we need to make 3 batches of this recipe for a large party, how many pounds and ounces of flour will you have in total? Okay, cool. So let's understand this a little better, because there's a couple of different ways we can do this, but there's a very simple way that we can go about this. Everybody, if we have 2 pounds, 5 ounces, how many batches are we trying to make? Yeah, we're trying to make 3 here. So pretty much what's going on here is we have this 3 times over. That is 3 batches. And when we add all of this up together, look at how friendly this problem actually is. So everybody, what's 2 plus 2 plus 2? What's that going to be? Yeah, that's going to be 6 pounds. Let's write that down right there. And then 5 plus 5 plus 5, what's that going to be? Yeah, that'll be 15. That'll be 15 ounces. Now, everybody, for the sake of being proper here, do we need to convert these ounces into pounds? Do we have enough ounces to convert into at least a pound? No, we don't. Pop quiz. How many ounces would we need to turn it into a pound? Yeah, we need 16. We're not there yet. We don't have 16. We have less than that. So this is actually already proper. This is already good. 6 pounds, 15 ounces is correctly stated. So we actually don't even need to convert in this problem. It was just a quick little scary for us because I am willing to bet, and y'all let me know in the chat box, and if you're watching this as a recording, just go ahead and just laugh it off to yourself. Who here was instantly nervous about this problem before you even knew what you had to do? Before you even knew that you didn't have to convert? See, this is what I'm talking about when I say basic strategy, the fundamentals, starting with the question, then the information, and then trying to understand the connection. When you stick to that basic strategy, my party people, you'll see that there are a lot more questions that you already know how to do. There are so many questions that you know how to do, but the fact of the matter is we just get in our own way. And that's what test anxiety is. That's what test anxiety is. And sorry about that. I highlighted A. It's supposed to be B. Excuse me there, everybody. Appreciate the patience on that. But I hope y'all understand that when there's a fundamental strategy involved, you give yourself the best opportunity to stay calm, cool, and collected. Does that make sense before we continue? Sweet. Again, practice, practice, practice. Proper practice makes perfect. So let's move on to the next one here. Everybody, what do we have? It says express this length in feet and inches. So everybody right there it is. Take whatever length they give you. We want it in feet and inches. So we've read the question. At the end of the day, we are just trying to turn some length into feet and inches. Now, if we read through the story, let's take it slow here. Let's understand what's going on. We're talking about our buddy Michael here, and Michael is building a wooden shelf for his garage. The total length of wood he needs measures 95 inches. Okay, sounds good. So we have 95 inches is what we're starting off with, and we're trying to end up with feet and inches. Okay, everybody. So what do we notice about this? Similar to how we've been tackling some of these other examples, what do we notice about starting with inches and ending with feet and inches? What do we notice about that? Exactly, there it is. Small to big, so I know I need to divide. There it is. I love this. So with that, let's write that down. We have a small unit going up to a big unit. So this is going to be division. And so with that, let's write that down. We are going to divide by what number though? We have to memorize this. What number are we going to be dividing by? Is it 16? Is it 12? Is it 3? Which one is it? Yeah, it's 12. Because remember, 1 foot equals 12 inches. And so with that, here we go. 12 goes into 95. Let's see how many times. How many times does 12 go into 95, everybody? Is it 7? Is it 8? Which one? Yeah, it's going to be 7. It's going to be 7 because 12 times 7 is 84. 12 times 7 equals 84. Don't forget that. So we know that it's going to be 84, so we'll subtract 84, and we have 11 left over. Everybody, what unit does the 7 specifically represent? What unit does the 7 specifically represent? Yes, 7 represents the number of feet because we were trying to group up 12 inches inside of 95. We can make 7 groups, and that means 7 feet. And so the remainder, the 11, what does that represent? What does the remainder represent? The remaining inches, right? Because we were converting inches to feet, and the remainder is the remaining number of inches. And so there we go. Boom. There's our answer. It's going to be 7 feet and 11 inches. And there we go. Hey, I'm glad that some of us are really starting to pick up on the confidence there with that. And so let me make sure I highlight the correct answer this time. B, 7 feet, 11 inches. And there we are. So with that, I'll give it a few moments here. But I just want to remind y'all that at first, new things are going to feel confusing, sure. But when you try to contextualize, when you try to wrap your mind around it, when you keep trying, something's going to give and you'll get better, no matter what. So don't give up. Keep trying, everybody. Are we ready for the next example? Perhaps one that you might want to try out yourself. Sweet. Sounds good. Let's go ahead and give it a shot here. I'm going to go ahead and put a timer around the screen, 2.5 minutes, and I'll give you a chance to try it out yourself. If you're watching this as a recording, try to do 2.5 minutes and give it a shot. And let's give this next one a shot. So, just like I said before I paused the recording, remember, we only accept, especially on standardized tests, we only accept problems or answers that are properly written. So everybody, quick question. If we have, let's go ahead and say, we're talking about someone's height. Have you ever seen someone's height listed as, let's say, 5 feet and 14 inches? Has anybody ever seen somebody's height listed that way? Right now, man, I could make myself seem like a basketball legend if I said that I was, 4 feet and 29 inches tall, right? I would be, come on, draft me, NBA, let's go, right? So no, that's not how it works. We want to speak about units of measurement. We want to speak about them properly. And so there's a standard procedure to how we do things, and it's by not going above what the next unit needs. So which of these answers is automatically going to be out, even if it's proper, even if it's the technical right length? Yeah, it's going to be A. A is wrong. A is wrong. 7 feet, 17 inches. I don't think anybody in the world would appreciate you giving that sort of measurement. So with that said, let's go ahead and begin from the beginning, starting off with the question sentence. The question sentence reads, what will be the total length of the joined pieces? Okay, sounds good. What will be the total length of the joined pieces? Quick question, everybody. When we are trying to find the total of two things that we're joining, what operation are we thinking of here? Yeah, we're thinking of addition, and you are absolutely correct to think that, especially in this context. When we see total length of joining things together, yeah, that's going to be addition. So I know that I'm going to be adding something, but the question really is, well, what? What am I going to be adding? And that's where you need to stop thinking about numbers, think about the story. Here we go. A carpenter needs to join two pieces of lumber end to end. Okay, so you have some lumber here, and then perhaps we have some lumber like that. And we're trying to join these two pieces of lumber together. Sweet, sounds good. Pretty simple, pretty straightforward. Now it says the first piece measures 5 feet and 9 inches. Second piece is 2 feet and 8 inches. So with that here, we have 5'9", and then we have 2 feet and 8 inches. And we said, everybody, clearly already that we would add. So before I continue, are we in agreement that we are supposed to add these two lengths together right now? Perfect. Let's get it done here. So if I add these together, there's a couple of different ways that we can do this. We can go ahead, one, just add the feet together, add the inches together, and then see what we're going to do next. That's a very appropriate way to do it. But again, you want to be careful of an overextension of a specific unit. But let's take things one step at a time. So in blue, I'll highlight 5 feet and 2 feet. Let's add those together. How many feet will that give us? 7 feet. Sounds good. And then I'll highlight this next one in, let's say, purple. Let me grab purple here. All right, so we have the 9 inches there and the 8 inches there. Add those together, my friends. What do we get? Yeah, we get 17 inches. 7 feet and 17 inches. However, everybody, like we just said, that's not a proper way of writing things out. That's not a proper way. But what do we know, everybody? What do we know? How many inches make up a foot? Chanel, Jaslyn, yes, appreciate you. 12 inches make up a foot. So let me just try to really show this by drawing it out. Everybody, 17 is the same as 12 inches plus 5 inches. Is that correct? Cool. That's what makes up 17. All I did was I took away 12 inches because that can be what? That is 1 foot. That is another foot. And what can I do with that additional foot, everybody? Where am I supposed to take that additional foot? Yeah, we want to move it up and add it with the 7. So if I take these two together, let me go back to highlighting in blue. If I take the 7 feet and the 1 additional foot, 7 plus 1, everybody, what does that give us? Yeah, that's 8 feet. So we have 8 feet and how many inches? And 5 inches. So if you're sitting here saying, Coach, I chose answer A, 7 feet and 17 inches, you are almost there. The right way to say 7 feet and 17 inches is 8 feet, 5 inches. Because we took the 12 extra inches that we had, threw it with the feet to make 8 feet, and then we had 5 inches left over. So who here on a scale of, let's use a scale. On a scale of 1 to 10, how much sense is what we're doing making? Right on. And at the beginning of class, I saw a ton of us being highly, highly, highly confused and nervous about it. This is a good improvement. Very good improvement. Remember, everybody, one day better, one day at a time, one problem at a time. Are you guys ready to try another one out on your own? All right, sounds good. So with this next one, you know that it's not always going to be as easy as just working with these convenient numbers. Notice how in this one, we had to add these together and then do a conversion. It's going to be happening perhaps again, and then maybe again after that. So let's appreciate the problems getting slightly tougher and slightly tougher, because this is how we ultimately raise that score. Here we go, everybody. And let's give this next problem a shot here. Again, one day better, one day at a time, one problem at a time. Everybody, can you tell me what's the goal of this question here? Can you just, again, one word or a phrase, what is it that we're trying to look for here? What's the goal? What is the goal? Right? How much flour, but more specifically about the flour, what do we know? What do we want to know? Yeah, how much flour in each container? So we have containers. We just want to know how much flour is going to be in one of those containers. Everybody, that's what each means. If I say, hey, me and my 30 friends won the lottery and we split the lottery amongst the 31 of us, how much money does each of us get? Well, each means one out of the bunch. So when we take a look at the information we have, let's be careful here, because it starts by saying a bakery receives a large bag of flour that weighs 75 pounds, wow, and 4 ounces. Okay, so large bag is what we have, and it is 75 pounds and 4 ounces. Okay, but really, don't worry about the numbers. Worry about what the numbers mean. So we have this bag that is, again, some number of pounds and ounces, whatever. But then it says they need to divide this flour equally among 4 storage containers. Everybody, what's the biggest word here that I should highlight? Yeah, exactly. It tells you exactly what math you need to do. It tells us divide right there. It tells us divide. And so because of that, we need to divide this by 4 containers. Perfect. So we want to divide that by 4 containers. Now, here's where the frustration is probably going to be setting in. Because, everybody, quick question. Is it easy to divide 4 by 4? Is 4 by 4 easy? Yeah, it's pretty easy, right? 4 divided by 4, that's 1. That's 1 ounce. 4 ounces divided by 4, that's 1 ounce. But 75. Everybody, is 75 divisible by 4? Is that a clean division? No, not quite, right? That's not quite a clean division. So for example, like if this was, let's say, 4 pounds and 4 ounces, and we were dividing that by 4, well, then that'd be easy, because then that would be 1 pound, 1 ounce. And that would be super easy. But in this case, it's not that easy. We don't have a whole number that we'll receive from dividing 75 by 4. So that's what the problem is. So everybody, what is the proper way to go about this? What is the proper way to go about this to make sure that we get a whole number amount no matter what? What do we need to do here? Who knows? Who knows? No, rounding would definitely be wrong because if you round in the beginning, there's no way to know a precise answer at the end. The correct answer, yes. Naomi, I think, is the first who said it. Let me make sure I give proper credit. And then Shane said change. So I'm going to count that as converting as well. Yeah, we want to convert. If we convert this into just ounces and then we divide by the 4, we'll be in a much better position. Let me go ahead and show you what I mean here. Everybody, how is it first? And I'm going to go ahead and take you through start to finish. But everybody, if I wanted to go ahead and turn the 75 pounds, all of that into ounces, what would we do to do that? We're going from a big unit to a small unit. Yeah, so we would multiply because again, pounds are bigger than ounces. So we are going to multiply by that 16. And I know this is going to seem like, oh no, these numbers are big. Don't worry. Think about the process that we're doing. Let me show you here. Let's do the 75 multiplied by the 16. And let me just move this a little bit this way, so that way I have a lot more room to work with. So if I do 75 times 16, bear with me. We'll first have 5 times 6, which is going to be 30, and we'll carry the 3. Then we have 7 times 6, which is 42. Carry the 3 is 45. Then we'll drop a 0 right here because we're moving to the next place value. So this is where we need to start. So let's keep it going here. 5 times 1, that's going to be 5. And then 7 times 1, that's going to be 7. When we add these together, my friends, what is it that we'll receive? We'll have 0. 5 plus 5 is 10. Carry that 1. 4 plus 7 is 11. Carry the 1 is 12. So this is 1,200 ounces. But let's be real careful. Is this entire shipment here that we're using, is it 1,200 ounces or are we forgetting something before we continue? Yeah, this large bag of flour, remember it's 75 pounds plus an additional 4 ounces. The 75 pounds is 1,200 ounces, but don't forget, we still had the 4 ounces right there. Before I continue, are we all in agreement that we have to add the 4 ounces back in before we continue? Cool. Great. I'm glad that was a very quick reply there. So let's go ahead and do that here. We will add the additional 4 ounces. Let me just highlight that there and just mark that right here. Let's add the extra 4 ounces that we had. And that puts us at 1,204 ounces. All right, everybody. Now that we're here, 1,204 ounces. What did we say we needed to do with this huge bag of flour again? We're going to be splitting it up, equally amongst those 4 storage containers. So let's take that next step. Let me just highlight the steps that we have right now. So this is step 1, step 2. Now let's go ahead and move it over here to step 3. Step 3, we're going to divide the 1,204 by 4. Now, once we do that, 4 doesn't go into 1, but 4 goes into 12. And that's going to be how many times, everybody? Yeah, that'll be a perfect 3 times. Good. 3 times 4 is 12. So I'll begin. Boom, we have a 0. Then we drop this 0, but 4 going into 0 is going to be 0. And then we drop the 4 right here. And then 4 goes into 4 how many times, everybody? Yeah, just once. So the division part, boom, was pretty straightforward. It's going to be 301. What again? What's the unit that we're currently at? Who knows? Who's paying attention? Yeah, we have ounces here because remember, it was 1,204 ounces, just splitting it up into 4 sections. We didn't convert here. We just split it into 4 sections. So it's still ounces, 301 ounces. Now that we're here, everybody, we're done. We're done. We have the final result. We split the 75 pounds and 4 ounces into ounces, except, oh no, what do we have to do because of what the answer choices look like? What do we have to do now? I'm not trying to ask for the operation. What's the word that I'm looking for? Yeah, we have to convert. We got to convert it back. Now, is this because, the world is against you? No, it's just what the problem requires. And now that we've identified what the problem requires, let's get to it. Because remember, the more time you spend complaining, the less time you spend overcoming. So here we go. We have to finish this up here by turning this back into ounces and pounds together. So turn into pounds plus ounces. And that is what step 4 is going to be. My party people, how do I go from ounces to pounds? Is that small to big, big to small? Yeah, that is small to big. When we go small ounces to a bigger unit pounds, we are going to divide. So let's now divide by what number again? Yeah, 16. So let's go ahead and do that, finish things up. We're going to do 16 into 301. Everyone, how many times does 16 go into 30? Correct, just one time. So we'll put that right there. We'll subtract the 16. 30 minus 16 is going to give us 14 left over. From here, everybody, we'll drop the 1. How many times does 16 go into 141? Or who wants to give me their best guess? Okay, some folks said 8. Let's give 8 a shot. And here's how we can test 8. We can do 16 times 8 just to give it a test. 6 times 8 is 48. Carry the 4. 1 times 8 is 8. Carry the 4 is 12. 128 is close enough because if you add another 16, that's going to put you at 144, which is going to be too much for what we have. So with that said, we are good. 128 is good. 8 is what belongs in there. And there we are. We subtract 128. My party people, let me know. 141 minus 128, or just 41 minus 28 because the hundreds cancel out. What's 41 minus 28? 13, correct. So here's how we're going to read this, everybody. The successful division, this is the number of pounds. And then the remainder is the remaining number of, ounces. And there is our answer. Again, if you still have reservations about how you feel about my torture method, my teaching methods, excuse me, guys, my teaching methods, then you can take it up with my boss that I don't have. But there it is. 18 pounds and 13 ounces is our answer, and that is answer choice B. And there we are. So my party people, let me go ahead and zoom back on out. Yeah, the process is a little winded, only because I explained every step. But when you think about it, everybody, let's go ahead and just reflect on this real quick. Think about it. What did we have to do? We had 75 pounds, 4 ounces, and we just needed to divide it by 4. That's all we needed to do. That's all we needed to do. And the way that we went about it, it just takes a little while. But everybody, do you believe that you can get faster at something like this with some time and patience and practice? Yeah, every one of us can. Every one of us can. And just check it out. 75 pounds, 4 ounces, we needed to divide it by 4. First, we turned it into just ounces. Then we divided by 4, then turned it back into pounds and ounces. When you read it like that, it sounds simple. But it just so happened that the numbers I gave you required some more steps. So everybody take a look at it. Was it the process that made it long, or was it the numbers that were used that made it long? Which one was it? Was it the process or was it the numbers? Yeah, it's the numbers. It was the numbers in this case. Yeah, and if you're still a little, if you're still refreshing, the process might be a little long for you. But ultimately, objectively speaking, it's the numbers here. It's the numbers that are going to make this longer. If I change the numbers up to, let's say, like 5 pounds and 4 ounces, and we wanted to divide it by 4, that'd be such a much easier problem. So I used 75 on purpose to show you and build confidence about the procedure. So with that, who's ready for another one? Sounds good, everybody. And remember, through every problem that you do, confused, correct, incorrect, so long as you keep trying, you will continue to improve. You will continue moving in the right direction. And we all know that if you keep going in the right direction, eventually you're going to get where you're supposed to be. So keep up the great work, everybody. Let's go ahead and move forward here to the next one. All right, So let's take a look at this next example here. Here in this problem, the goal, again, when we read the question sentence, here it says, express this travel time in hours and minutes. And if we read the first sentence, given how short the problem really is, we see that it says, Sarah's train journey from Boston to New York City, takes 255 minutes. So if we understand this properly, we are starting with 255 minutes, and we need to turn this into hours and minutes. So when we take a look here, everyone, well, we are taking this as a small unit going to a bigger unit because minutes are smaller than hours. I think we can all agree there. And everybody, what did we say we should do when we are going from a small to a big unit? Correct, division. That is division. We will divide. Now, although we haven't gone through it yet in today's class, I think we should all know this. What number are we supposed to be dividing by? How many minutes are contained in 1 hour? Correct. 60 minutes encompass 1 hour. 1 hour, 60 minutes. So that is the value that we will be dividing by. Now let's get to work here. I'm going to divide 60 into 255. Again, 255 divided by 60. And so now that we're here, everybody, how many times does 60 go into 255? That'll be 4 times. So what does the 4 represent, everybody? We have made 4 groups of 60. The 4 represents what? Hours. Yeah, 4 whole hours. Boom. Now we need to understand what the number of remaining minutes are. 60 times 4, that's going to be 240. And when we subtract 255 minus 240, that's a remainder of 15. 15 remaining what? What units should we use there? Correct, minutes. 15 remaining minutes. And there we go. A very straightforward one. I had to kind of, toss you a much more doable one after that very, very lengthy one. But nonetheless, the correct answer here will be 4 hours and 15 minutes. That would be choice B in this case. Now, everybody, just want to remind you, the only difference between the previous question and this one, in a lot of ways, is just the numbers. It's really just the numbers. So keep up the great work here. Let's go ahead and turn our attention over to the next problem. Let me go ahead and pause this here and let's keep it up. And let's give this next one a shot. And I want to go ahead and shout out Alec. I love that comment. My brain is doing things in ways I never thought it could. Right on. And we're not talking about the stock market. So with that, think about it, everybody. Who else here feels like they're making progress? Like conceptual progress. Like actually understanding what's going on. See, this is what you want to capture. You want to be able to talk about what you do at the end of the day. That's what's going to spell progress. So let's go ahead and give this one a go. First things first, read the question first. The question reads, how much will they spend? That's it. It's a very straightforward question, right? How much are we going to spend? Sounds good. How much will they spend? We want to know how much money. Let's read the story now to understand what's going on. Typically, I would start from the very beginning, but because the question sentence came after a conditional, came after a comma, then I know that this is conditional information that I should probably write down. So let's go ahead and start off with that. So a customer purchases 1 pound and 5 ounces of tea. Let me highlight that right there. Purchases 1 pound, 5 ounces. So we buy 1 pound, 5 ounces. Great. And now let's start with the first sentence. It says, a specialty tea shop sells loose leaf Earl Grey tea for $3.20 per ounce. Just a side note, Earl Grey tea is awesome. Just don't ever drink it after 5 p.m. There's a ton of caffeine in it. I've made that mistake before. So with that again, the Earl Grey tea was $3.20 per ounce. Let's highlight that as well. $3.20 per ounce. Okay. Now, everybody, let's think about this. Let's really wrap our heads around this. Everyone, if it is $3.20 per ounce, what is it that I need to multiply by? What should I multiply the $3.20 by? Now, y'all are saying, y'all are putting numbers in the chat box. I do not want numbers. No, 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 no. I want a concept, an idea, a unit. What am I supposed to be multiplying the $3.20 by to get the final cost? Yeah, you don't even need to put a number, just ounces. Just ounces. Let's go ahead and write that down so it makes a lot more sense. $3.20 per ounce multiplied by the number of ounces equals the final price. Everybody, does that make sense? Like, if something costs, let's go ahead and say over here, like, let's say something costs $5 per pound. Well, multiply by the number of pounds and you get your final price. If you're trying to buy some fencing that costs $50 per foot, multiply by the number of feet, right? So in this case, it costs $3.20. Don't even worry about the number. It costs this much per ounce. So we need to multiply by the number of ounces. That's the logic that we're using. And so with that said, everybody, am I just going to take the 5 right here and just throw that right there? Is that what I'm supposed to do? Is that what I'm supposed to do? No, exactly. Not at all. Because sure, 5 ounces is part of the number of ounces, but we forget that a pound is a certain number of ounces. Everybody help me out. How many ounces is 1 pound? 16. If you remember that fact in this specific problem, oh yeah, we're feeling pretty good about this one, right? So we'll have 16 ounces plus 5 ounces. Let me highlight this, highlight that, and that gives us 21 ounces. And once we have that, now we're good to multiply. Now we're good to continue. You just have to hope that you remember how to multiply by decimals. And that's what you have me here for. I got your back. Let's go ahead and get that done. Let me zoom on in and let's get $3.20 multiplied by 21. And just to remind you about the rules for multiplying by decimals, don't. Just ignore it. Ignore the decimal, do your multiplication, and then bring the decimal back at the end. So let me show you here. So 0 times 1, that's going to be 0. 2 times 1, 3 times 1, excuse me there, sorry guys. Let me go ahead and just move that back forward. Sweet. So then, yeah, 3 times 1, that's 3. Let me erase that. And now I'll begin by placing a 0 because I'm going to start with the 2. And I got to start at the right place value. So with that, here we go. 2 times 0, 2 times 2, that's going to be 4. 3 times 2, that's going to be 6. Add everything all back up. 0, 2, 7, and 6. And everybody, the way that we handle it at the end, we are going to bring back those decimals. So we're looking at this here with the 21. That's nothing. But we have 1, 2 decimal places here. And that's what we're going to bring back. 1, 2. And there our answer is $67.20. Again, you should only spend that much money on tea if it's worth it. And Earl Grey tea is worth it. But there it is, my party people. The correct answer here is C. If you thought the answer was going to be B just because the last 4 answers were B, haha, I got you. But besides that, how are we feeling about this one, everybody? Where, again, another different type of question, but it still involves unit conversions. Right on. Good. Yeah, I might not be cooked after all. I love that comment. So everyone, here's the main piece of advice that I have to give you in this, in this lesson here today. The biggest lesson of all is unit conversions. They can appear in really any topic. Unit conversions can appear in decimal problems. Unit conversions can appear in proportions. Unit conversions could appear in percentage problems, in distance rate time problems, in area and perimeter problems, in volume problems. Unit conversions can appear in any topic. So you should not be practicing unit conversions in only one way. You have to be prepared to apply unit conversions within a problem that requires it. basically like a detour in the problem that you have to convert in the middle of. Everybody, does that make sense before we continue here? Does that make sense that we must make sure that we keep our mind open? Like, just because we see a distance rate time problem doesn't mean we won't have to convert a unit in there. We've got to be prepared to do it when we're called to do it. Perfect, everybody. That's the biggest part of today. That's the biggest lesson. For as many problems as we'll do for unit conversions, they can appear in any topic at all. So with that, this is the time where we're going to move forward and get that practice in the program while we wait for the next lesson. And that's how we're going to continue mastering this.